On the notes that I just handed out, it says specific outcomes, solve problems using the three primary trig ratios for angles. Now, our primary trig ratios up till now have been SOHCAHTOA, opposite over adjacent, opposite over hypotenuse, adjacent over hypotenuse, etc. But now, in grade 11 and in grade 12, we're always going to have our trig ratios on a Cartesian plane. So they're always going to be x's and y's, and then our radius. Because what we're going to be having is we could have a circle. We're going to draw a unit circle so that hypotenuse actually becomes the radius of a circle. You could draw it all the way around. Okay? So we're going to go through how the trig ratios change. So sine, if I drew one here, let's say I drew it at 3, 3. Okay? If I drew my reference or my angle going through 3, 3 like this. My angle is always the central angle, so this is always my angle here. This is my hypotenuse. This is my what of that? Opposite or adjacent? Opposite. And then this is my adjacent. We know that, correct? So what does the adjacent go with? X or Y? X. My adjacent will always be my x. So wherever I would put adjacent in my SOHCAHTOA, I'm going to put x. Wherever I put opposite in my SOHCAHTOA, I'm going to put y. And hypotenuse, I'm always going to put r. Because it could be the radius. Because what's going to happen is we're going to get like a unit circle rotation like this. So that's actually my radius. So it's so it's sine equals opposite over hypotenuse. Ka, adjacent over hypotenuse. TOA, opposite over adjacent, which is great, and that can help you get your x's and y's and r's from now on. Because remember, x is just your adjacent, O is just your y, and then hypotenuse is just your r. So the trig ratios we're going to use from now on are sine theta equals y over r, cos theta equals x over r, and tan theta equals y over x. Now someone many moons ago came up with, one class helped me, and we came up with acronyms for these. They're really bad, but just wait. They're really bad, but they work. Ready? So this one is sine, which I'm going to spell it that way just because it is sine. Sine your resume.
No, I'm not writing them. Yeah.
You cannot write them down, but they're going to be the way you're going to remember it. Sign your resume, and next year you're going to have 3 more trig ratios. And then cook extra rice with an X. And then when in doubt, tan your Xbox. So it doesn't lack vitamin D. Yeah. So sign your resume, cook extra rice, tan your Xbox. So, the xiphoid process is what someone else came up with. That was excessive. So we used Xbox. Okay. So just tan that. Yeah.
That makes sense.
Sure. Bless you.
Achoo.
So we are going to do the trig ratios if we're given coordinates. So what we did on Friday is I gave you a coordinate and asked you for the angle and standard position, correct? When I gave you a coordinate and asked for the standard position, you need to see and know what to do. Because I'm going to give you a coordinate today and ask for trig ratios. I gave you a coordinate on Friday and asked for the standard position angle. So when I give you a coordinate and ask for standard position angle, you take that coordinate, get it into tan positive, and get the reference angle, give you the angle, correct? Today, if I give you a coordinate and I ask for a trig ratio, you're going to have to find the third side first, because I need x, y, and r, and I'm only giving you x and y. The key thing to know is r is a radius. Radius is a length of measure, okay? So r is always positive. R is always positive. So, if I go to sketch this one, we could sketch it above, but I'm just going to sketch it over here. So I'm going to sketch -3 and 4. It's right here. I can draw my angle like this. First thing I want you to do is actually just get me the standard position angle, like we did on Friday. So do that first. So we are going to go take our little triangle out, like we did before. This is my theta. My x is -3. My y is 4. If I want the reference angle, I'm going to go tan -1 of, or tan theta, sorry, get a little ahead of myself. Tan theta, so this is for the reference angle. We get tan theta equals tan your x box, so this is going to be y over r, so your y is 4, or y over x, so it's 4 over 3. Why did I do 3 and not -3? Because when you find your reference angle, you always take what of the fraction? The positive fraction, the positive fraction, the positive fraction, the positive fraction. Okay? Every single time. So then we go tan -1, so reference angle equals tan -1 of 4/3. So I go second tan 4 divided by 3, and I get 53.1 whatever. So I'm going to say 53. So this angle in here is 53. We agree? So what's the standard position angle? Theta is going to equal 180 minus 53. So theta equals 127. So this angle here is 127. Now I know I have a triangle, -3, 4. I know x equals -3. I know y equals 4. I know a sine is sine your resume. So I'm going to get 4 over I don't know. Cos is cook extra, so -3. Rice, I don't know. And then tan your x box, 4 over -3. Now I actually keep the negative in this case, because the only time I don't take the negative is if I'm looking for the reference angle. Correct? I can't finish 2 of my trig ratios. Why? I don't know my hypotenuse. So what do I use to get my hypotenuse if I know 2 sides? The Pythagorean theorem. So you get x squared plus y squared equals r squared. Right? Because the 2 sides are x and y, and r is the radius. So we're going to do r squared equals x squared plus y squared. It's just Pythagorean theorem. R squared equals x squared is -3 squared, and y squared is 4 squared. Now remember, when you square a negative, it becomes positive, and if you don't put it in your calculator with brackets, it's going to tell you it's negative. So -3 squared is 9, plus 16, which is 25. So we're going to get r squared equals 25. Now, we have to take the square root. Whenever you take the square root, you take plus or minus the square root. You actually get 2 answers. So when I take square root of 25, I get positive or negative 25. So I get root 25, sorry. So I get r equals plus or minus 5. But what did I tell you about r? It's the radius. And what did I tell you about the radius? It's always positive. So r is actually just 5. And I can finish my trig ratios. 5, 5. Okay?
Do you want us to show that on the test, the plus or minus 5?
Yes. So here we have 3/4. Or 3/4. Girl, please. No, we don't. We have 3, 4. It is a coordinate. Let's draw it. So you have 3, 4. So if I want the standard position angle, it's going to be the reference angle, correct? Because it's in quadrant 1. So reference angle equals, we do it by going tan, theta, and we have our little triangle. It's like this time. Ooh, what the heck is that? So we have 4. And then 3. Ah, what am I doing? I don't know. That's true. Okay, so tan theta equals tan your x box, so it's 4 over 3. And then theta equals tan neg 1 of 4 over 3, which is 53 degrees. Wait a second, it didn't change. Why didn't it change? Because whether the coordinate is negative 3, 4, 3, 4, negative 3, negative 4, 3, negative 4, I'm going to be dividing 4 by 3, positive, for the reference angle every single time. So the reference angle of all 4 of these is going to be 53. Because what do? I divide my y by my x, positive, right? So this one's going to be 4 divided by negative 3. Nope, 3. This one's going to be 4 divided by 3. This is going to be 4 divided by 3, because even though they're negative 4 and negative 3, it doesn't matter. Negative 4 divided by 3 is going to be 4 divided by 3, because the reference angle is always positive. Do you see that? So the reference angle isn't changing for any of these. The angle is going to change. Standard position angle is going to change. The reference angle isn't going to change. So I know my reference angle is 53, and because it's in quadrant 1, my standard position angle is 53. Because they're the same in quadrant 1. Now, I have 3 and 4. What's my radius going to be? 5. Is it going to change? No, because what am I going to do? I'm going to go r squared equals 3 squared plus 4 squared, which is still 25. Because whether I square a negative 3 or I square a 3, it's going to end up being 9, right? Square root of r, square root, plus or minus. So r equals plus or minus 5, and in this case r equals 5. So my triangle is now 3, 4, 5. It's often easier if you actually label it. So I know x equals 3. I know y equals 4. I know r equals 5, because it's 3, 4, 5, right? X is 3, y is 4, r is 5. And then I just do my trig ratios. Sign your resume. So it's going to be 4 over 5. Cook extra rice. So it's 3 over 5. Tan your Xbox 4 over 3. Okay. Negative 3, 4, and 3 and negative 4. Try them out. I want the angle in standard position. We all know now that the reference angle is 53 no matter what, right? You're just going to have to draw it in quadrant 3 for this one and quadrant 4 for that one. And then I want you to give me the 3 trig ratios. So this one is in quadrant 3. We know it has a reference angle of 53. We also know it has a coordinate of negative 3, negative 4. My angle in my standard position angle. How do I find it in this quadrant, in quadrant 3, if I have the reference angle? Anyone remember? How do I get it from here to here? Yeah, 180 degrees plus 53, which is 233. And then if I have negative 3 and negative 4, what's my r still going to be? Positive 5. right? 3 squared plus 4 squared. If I go negative 3 squared plus negative 4 squared, or I go 3 squared plus 4 squared, I go negative 3 plus 4 squared, or if I go 3 plus negative 4 squared, it's the same thing, because when you square a negative, it becomes positive, correct? I'm not changing what my x's and y's technically are to find r. So r is still 5. So now I go sign your resume. This is y, this is x. So sign your resume, negative 4 over 5. Cook extra rice, negative 3 over 5. Tan your Xbox, negative 4 over 5. This one, we're in quadrant 4, so we're at 3, 4. 3, sorry, negative 4 over here.
Oh, you said not tan her Xbox.
I tanned something else. What did I tan? I don't know. I tanned your resume. I tanned my rice or my resume. I don't even know what's going on. Tan your Xbox. Ah, 4/3.
I think that's greedy word.
Okay. No. Okay. How do we get the standard position angle in quadrant 4? It's 360 degrees minus 53, which is 307 degrees. So 307 degrees makes sense. If I have x equals 3, y equals negative 4, r is still 5. So I get sign your resume, negative 4 over 5. Cook extra rice, 3 over 5. Tan your Xbox is negative 4 over 3. Yeah. Yeah. Okay, we're going to flip over. There are 2 examples on the next page, both of which I want you to do the exact same thing, but now you're going to have to do a little bit more work because it's not the same 53 degrees. But it's just 2 new coordinates. So here we have negative 2, negative 3. Here we have negative 6 and 4. I want the angle in standard position first, and then I want sine, cos, and tan, the trig ratio. So it's the exact same. You just have to find the reference angle and r. Try it out. So we have negative 2 and negative 3 lie on the terminal arm of angle theta. So let's draw it first. So we have negative 2 and negative 3. So we know we're in quadrant 3. We agree? We're going to learn about casts soon, which is going to be cool. Okay. Not cats, cast.
Well, yeah, I actually hate cats.
Well, we're not learning about them, so you're okay. So we're going to use always the triangle that forms the bow ties, right? We always use the triangle that forms the bow ties. So if I pull that triangle out of here, I'm going to get this. This here is negative 2. This here is negative 3. If I want the angle, the full standard position angle, this whole full standard position angle, I need to get the reference angle first. We agree? So what do? We tan theta, always positive. Always positive, always positive, always positive. If I can drill that into your brains, then when you hit next year, you won't have to drill it in. It'll be drilled. It'll be embedded. Deep, dark depths of your brain. Okay? If you're someone who's doing 30-1 in calculus, you're going to be doing 30-1 first semester because calculus is second. So you'll have back-to-back math, which is good. You'll only be able to lose a little bit of it over summer. Okay? It's deeply embedded into your brain. That's my goal. So we're going to find the reference angle. And how to find the reference angle, when we're given a coordinate, we're always going to use tan. And why are we always using tan? Because I give you x and y, and tan is x and y, correct? So that's why when I give you a coordinate, to get your reference angle, it's always going to be tan. So tan theta equals tan your x box. So your x box, y, x. Right? Because this is y and this is x on the Cartesian plane. You see that? And I took 3 over 2, and people are like, but it's negative 3 over negative. Doesn't matter. Remember, reference angle always positive, so it pops us into quadrant 1. And we get a reference angle, okay? So what does theta equal? Reference theta. What'd you get? Because you have to tan neg 1 both sides. What'd you guys get? hear over the whispering. Tan theta of 3 over 2 is
56.
what? 56. Did everyone else get 56? Okay, that's the reference angle. That is not my angle in standard position. How do I do my angle in standard position when it's in quadrant 3? What do we do? If I get my reference angle is 56, which seems realistic to how this is drawn, right? It should make sense. If you're drawing on a Cartesian plane with an actual coordinate. How do I get the angle in standard position? 180 plus 56. Because it takes me 180 to get to here, plus 56 more. And you get 236 degrees. Now I want my trig ratios. What am I missing in order to get my trig ratios? R. So I have to use Pythagorean theorem. So I'm going to get r squared equals negative 2 squared plus negative 3 squared. So r squared equals 4 plus 9. R squared equals 13. Then I take the square root. When I take the square root, must I always take positive and negative? It just happens that r is always positive. There are going to be times I'm going to solve for x and y. X and y do not always have to be positive or negative. They can be both, right? So that's why you need the plus or minus sign, and then figure out what quadrant, and then you'll know if it's plus or minus. Now, root 13, can I reduce it? We've done reduced radicals over and over and over. We used it in quadratics even. Can I reduce 13? No, so it's going to stay. So let's look at our trig ratios. We're going to have sine, and now, if you have sin equals, but you don't have the theta, you have the word sin. That's all you have. You have the word sin. It's bad things. Okay? You need sine theta, and then it's actually the word sine. You need to have a theta beside it. Why do I say that? Because on the test, 95% of you will just write sine and not put the theta. So make sure you have the theta. Everyone have it? Put down your phones, put down your phones, put down your phones. Put down your phone. One in every crowd. Okay, stop it. So it's sign your resume. Paying attention. I'm going to get negative 3 over root 13, and that's what most of you will have. They are always going to rationalize their denominator. Denominator being bottom, rationalize meaning not square rooted. Okay? Are you paying attention? This is a little lesson you're going to learn right now. It is not hard. How you rationalize your denominator is you multiply by the square root of that. So if it's root 13, if I multiply it by root 13, I'm going to get 13. This is why. If I have root 2 and I multiply by root 2, I get root 4, which is 2. If I do root 3 times root 3, I get root 9, which is 3. Root 10 times root 10 is root 100, which is 10. When you multiply two radicals that are the same together, you get just the number under the radical. Okay? So let's try it out. If I multiply this one by root 13, when I do the bottom, I have to do the top. If I just do it to the bottom, I've totally changed my fraction, right? So I have to multiply the top by it. So I'm actually going to get negative 3 root 13 over 13. Do you see that? Because root 13 times root 13 is root 169, which is 13. That's why when you multiply two radicals that are the same together, you multiply what's underneath them together. And you'll get just the number. Okay? Then cos. Cos theta. Cook extra rice. So I'm going to run into the same problem. I have a root 13 on the bottom. How do I get rid of it? Times by root 13. So I'm going to get negative 2 root 13 over 13. And the only way I can reduce is if these two numbers, the 2 and the 13, have something in common. And do they? No. So it's going to stay. And then tan theta is tan your x box. So I'm going to get negative 3 over negative 2, which is just the same as 3 over 2. You can just take off the negative signs, because a negative divided by a negative is a positive. Now we're going to try this one. So we have negative 6 and 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Negative 6 and 4. So I want to get the reference angle first, correct? Because I want the angle in standard position. When I give you a coordinate, it's an x and a y, so I can use tan. So there's my thing. This is negative 6. This is 4. So I can draw my little triangle out here. X equals negative 6. Y equals 4. And I can find the reference angle. I do tan theta equals tan your x box. So do I go 4 over negative 6 when I'm finding the reference angle? Do I go 4 over negative 6? When I do the reference angle, I always do positives. So I'm going to go 4 over 6. And then theta equals tan neg 1 of 4 over 6. So I get 34. And that's my reference angle. So this in here is 34. So how do I get the standard position angle? 180, what? Minus 34. Which equals 146. So that's my angle in standard position. So we have sine cos tan. Sine cos tan. What do I need first in order to get my trig ratios? I need to find r. So I'm going to get r squared equals 4 squared plus negative 6 squared. R squared equals 16 plus 36. R squared equals 52. Square root, we get plus or minus. So R equals positive root 52. 52, can I break it down into anything? I think 4 and 13, isn't it? So R is 4 times 13. The 4 comes out and it's a 2. We're just using grade 10 again. Grade 10 never goes away, just so you know. We use it almost every day in 30-1 as well. Never goes away. So R is 2 root 13. Do you see that? Everyone understands that. Everyone agrees with that, correct? Okay, so let's do our trig ratios. Sine theta. Make sure there's a theta or you would just have the word sin. Sine theta, y over r. So y is 4 over r, which is 2 root 13. I forgot to write up here. I don't care about the 2. The 2's fine. It's the root 13 that's my problem. How do we get rid of a root 13? Multiply by root 13, right? It's the same thing. So on the top, I'm going to get 4 root 13. And on the bottom, what's root 13 times root 13? 13. And then I have to multiply it by The 2 in front. So what's 2 times 13? 26. And now I told you, if you can reduce these two numbers, then you do. Can I take anything out of 4 and 26? You can take out a 2. So the 4 would become a 2, and the 26 would become a 13, and my answer would be 2 root 13 over 13. Then we have cos theta. Cook extra rice. So we're going to get negative 6 over 2 root 13. What's my problem? The root 13 in the denominator. How do I get rid of root 13? Multiply by root 13. Right, do the bottom, I have to do the top. So I'm going to get negative 6 root 13 over 2 times root 13 times root 13 is 13 times 2, so it's 26. Can I take anything out of 6 and 26? You got a 2. So the negative 6 becomes a negative 3, and the 26 becomes a 13. So we get negative 3 root 13 over 13. And then tan is the best thing ever because it's just easy. Tan theta is tan your x box. So we're just going to get 4 over negative 6, which can reduce to 2 over negative 3. Now, guys, I need to show you something. You're taught this in grade 10. You're taught this actually in junior high, but I just want to show it to you. When you have a negative sign, they can write it as 2 over negative 3. They could also write it as negative 2 over 3. Like they can make the negative move to the top. It's the same answer, right? Or they could write the negative in front. Those are all equivalent. So just because you get 2 over negative 3, the answer might be negative 2 over 3. It's the same thing. Because if I go negative 3 over 2, let's just aside this. Don't write this down here. I'm just showing you something. If I go negative 3 over 2, that's negative 1.5, correct? We agree? If I go 3 over negative 2, that's negative 1.5 as well. And then if I go negative 3 over 2, that's a negative sign, and then 3 over 2 is 1.5. It's the same answer the whole way through, right? No matter where that negative, it just can only have one. So your homework for today isn't a lot. Just practice. You just practice doing, I'm going to give you coordinates, and you have to give me the trig ratios and the standard position. Okay, so it's page 96. Number 5. Number 5.
I'm wrong.